Alright, we talk about two more rules that are new in this section 9.6, the chain rule and the power rule. The more difficult one to understand is the chain rule. Sometimes the chain rule is talked about as the rule of the hand. And so the reason for that is you've got a function within a function. You've got an interior function g and an outside function f. And the way that you take the derivative of something like that is you cover up the inside function with your hand, and you only take the derivative of what you now see, which is just derivative of f. And the interior function is untouched. But then you multiply that by the derivative of the interior function, or the derivative of what you covered with your hand. So if you've got the chain rule here with the square root of x squared minus 1, which is this x squared minus 1 raised to the 1/2 power, you cover up the interior, and you're now taking the derivative of something to the 1/2 power. So you bring the 1/2 out front and subtract 1 from the 1/2. And notice the inside is untouched. But then you follow it with the derivative of what's inside. And the derivative of x squared minus 1 is just 2x. And the rest of that is just cleaning up. Now in this one, example 3, they give you the outside function, and they tell you the inside function's derivative. They don't really tell you what the inside function is other than just referring to it as L. So when they ask you to take the derivative of w with respect to t, you're taking the derivative of w with respect to L and the derivative of L with respect to t. Derivative of w is just 10.375 times 3L to the second. And then the dl dt is just what they give you already. That's the derivative of the inside function. And so this guy times 3 times L squared times this gives you the first term. And this guy times 3L t squared times that gives you the second term. So here's your derivative of w. It's the rate of change of the weight of the fish based on the length of the fish. And so part B says if a fish weighs 30 kilograms, approximate its rate of growth in weight used in formula found in part A. Well, if the weight equals this, which is the original formula they give you, and we know that the weight is 30, we can say, instead of w, we say 30 equals this. And we can solve this for L. We can divide by 10.375, and we can take the third root. That takes away the third power. And so now you know that L equals 1.4247 meters when the weight is 30. So now you know the length when the weight is 30, and now you can plug that into the function to find the rate of change of the weight based on the proper length. And when you do that, you get a rate of change of 6.542 kilograms per year. So this fish is growing very fast. That's about 13 pounds or 14 pounds per year. That's a really large growth factor there. All right, now what is the second rule we're using? The power rule. So if y equals u to the n, you just bring the n out front and subtract 1 from the n, but you have to take the derivative of what's inside, which is the derivative of u, or u prime. And so if you're talking about the power rule here, you bring the 6 out front and subtract 1 from the 6, and you get to the 5th, and then you follow with the derivative of what's inside. Alright? And then for this one, if we're taking the derivative, we can rewrite that with this guy raised to the -1, right? And so now when we take the derivative of this, we cover up the inside, and we bring the -1 out front, and we leave the inside untouched, and we subtract 1 from the exponent, and we follow with the derivative of what's inside. And now the rest of this is just simplifying. Now we could have used the quotient rule, but the power rule is more efficient here when we're doing this. Now what about the power rule with radicals? Well, if you got 3 times the cube root of this, you can say that's to the 1/3 power, right? So you get 3, and then you bring the 1/3 power out front, and you subtract 1 from the 1/3, leaving you with -2/3. And then you follow what's untouched in the inside by the derivative of the inside, and you get this guy here, and then you clean it up. And then this one, you can raise the second root and third power. That means the exponent is 3/2, and when you cross the fraction bar, it makes it -3/2. And now the derivative is just bringing the negative 3/2 out front, subtracting 1 from the exponent. Inside is untouched, followed by the derivative of what's inside. And the rest of that is just cleaning up. Now this one, when you take the derivative here, the 98's out front, but you bring the minus 1/2 out front and subtract 1 from the minus 1/2. Inside is untouched, followed by the derivative of what's inside. And then when you multiply the minus 1/2 times the 2 times the 98, you get 98. And this guy is left the way it is. Now they ask you to figure out what's happening when the price is 24, so you plug in 24 for P and you get your answer. And so when the price is 24, the demand is changing at a rate of negative 2/7 hundredths units per dollar. 2/7 is about 0.28. So 0.28 times 100 is around 28 units per dollar, or 29 units per dollar. So now let's look at some questions that are similar to the ones you'll see on WebAssign. When they ask you to take the derivative of this guy, 3/4 times this function raised to the 8th, you take the 3/4, leave it out front, you bring the 8 out front and subtract 1 from the exponent. Inside is unchanged, followed by the derivative of what's inside. And now the rest is just cleaning it up. This one, again, you bring the negative 2 out front and subtract 1 from the exponent. Inside is unchanged, followed by the derivative of what's inside. And the rest of this is just cleaning up. This one, you probably want to bring that upstairs and write it with a negative exponent, negative 3/4. So when you bring the exponent of negative 3/4 out front and subtract 1, this is what you get, and the inside is unchanged, followed by the derivative of what's inside. And the rest is just simplifying. This is raised to the 1/2, so you bring the 1/2 out front and subtract 1 from the 1/2, leaving you with minus 1/2. Inside is unchanged, followed by the derivative of what's inside. 25, you have this guy raised to the 3rd power, so you bring the 3 out front and subtract 1 from the exponent, followed by the derivative of what's inside. And now they plug in 2, since x equals 2, and you get an answer of 3, so now you know your slope is 3, and you got the point 21. You can find your equation of the tangent line that way. 27, this is raised to the 1/2, so you bring the 1/2 out front, subtract 1 from the 1/2. Inside is unchanged, followed by the derivative of what's inside, and the rest is cleaning up. And now for 27, they want you to use x equals 3, so you plug 3 in for x, and you get your slope is 9/5. So now we know our slope is 9/5. You want to find the y-coordinate of your point where x equals 3, so you plug that into the original function. So you got your 1 point, and you got your slope, and now you can find your equation of the line. And here's the graph that justifies all that. 28, you bring the minus 3 out front, subtract 1 from the minus 3, and take the derivative of what's inside, clean it up. You plug in 2 into the function, and you get your slope. Plug 2 into the original function to get your y-coordinate of your slope, or y-coordinate of your point. We know the x-coordinate is 2. We now know the y-coordinate is 1 over 2/16. And we know our slope is negative 11 over 432. So you plug that in for your slope, you plug this in for your x1 and this one for your y1. Multiply everything out, and then you multiply everything by 432 to get rid of your fractions, and then you solve it for y and you get this guy here. Okay, they give you a ballistics and they want you to take the if this is the distance that something travels, which is another word for saying the position function, the derivative is the velocity function. If you take a function that is a position function, its derivative is velocity. And then if they ask you to find the velocity, all you have to do is take the derivative. And so you do. You bring the 3 out front and subtract 1, you get 2. And then follow that by the derivative of what's inside. And so there you go. You plug in the value they want. They say t is 1/10, so 0.10. Plug that into the function, and now you know the velocity at 1/10 of a second after it hits the paper. 37, the revenue function is given here. They ask you to find marginal revenue, so you're taking the derivative here. Well, the derivative of 1500x is just 1500. Derivative of this, well, the derivative of the constant is 0. But derivative of this, you're bringing the negative 1 out front and subtracting 1 from the exponent, followed by the derivative of what's inside. When you clean everything up, this is your derivative of the revenue function, or marginal revenue. And they want you to plug in 100. And there you go. And so if you plug in 100, this tells you the change in revenue for the sale of the 101st unit, the next one after 100. Right? 39, they give you the weekly sales here, and they want you to find the rate of change of the weekly sales, so you're taking the derivative of that. So you bring the minus 2/3 out front, subtract 1 from the minus 2/3, followed by the derivative of what's inside. You clean it up a bit. Now you plug in 21, which is the number they want you to use, and you get this. And so you can see the price changes by, if the price changes by $1, meaning from $21 to $22, then the weekly sales volume will change by approximately negative 0.114 thousand units, or it will drop by 114 units. When you multiply 0.114 times 1,000, you get 114. Stimulus, magnitude of sensation Y. They want you to find the, for the stimulus of brightness here, they give you this. They want you to find the rate of change of the stimulus or sensation. So you have to take the derivative of this guy. K is a constant, and we don't know what it is, so we just leave it out front. You bring the 1/3 out front and subtract 1 from the 1/3, and follow that by the derivative of what's inside. K sub 0 is a constant, so its derivative is 0, and the derivative of x is just 1, so you don't have to write down that 1. You can if you want. But then when you clean this up, the 3 goes in the bottom, and this guy comes down and is to the 2/3 power. This one, when they want you to take the derivative here, you think of that as raised to the 1/2 power. You bring the 1/2 out front, subtract 1 from the 1/2, leaving you with minus 1/2, followed by the derivative of what's inside, which is just 4. And now 4 times 4 is 16, times 1/2 is 8, and this guy comes down and is written as the square root instead of 1/2 power. On this one, when you take the derivative, you bring the 240 out front and subtract 1 from the exponent, followed by the derivative of what's inside. Derivative of 1 is 0, and this is 0.01 over 12 times r, and its derivative is just 0.01 over 12. When you multiply this times 240 times 1,000, you get 200, and this part doesn't simplify any farther. And now here they ask you to find the if the interest rate is 6%, what is the rate of change of S? Here, normally when you think in mathematics with interest rates, you want to write it as 0.06, but they actually want you to use the number 6. So you plug 6 in here, and you get, if the interest rate changes from 6% to 7%, the amount of investment would change by $658.75. Then here you plug in 12, and you get this number. And so if the interest rate changed from 12% to 13%, the amount of the investment would change by $2,156.94.